Hi, and welcome to the second day of the Azure SQL Bootcamp. I'm Anna Hoffman, a data and applied scientist on the Azure SQL team, and I'm joined once again by Bob Ward, a principal architect on the Azure data team. Thanks for being here again, Bob.
Anna, great to be back. It was a pretty amazing session yesterday we had.
Yeah, we covered some fluff, but I would say we covered a lot of content.
Yeah, I call it fluffy. I'm sorry. I just love diving deep into things. We really did cover a lot of information. And, based on the questions that we received during our session, it's very clear to me that we need to continue to educate our community on what is Azure SQL. What is a managed instance? What is a VM? What is a database? When would you use these different options? And so I would encourage you, if you're listening today, to go back at a later point in time and watch yesterday's session to make sure you understand when you would pick one of those options, either a SQL Server and a VM, a managed instance, or a database, and how that applies perhaps to the requirements, for your application.
Definitely. And if you go to the URL that was on the screen, you can access all of the videos from this series even after the series is recorded, as well as our 61 video series where we go through all of this, sometimes in a little bit deeper fashion because there's no time limit. But today, we're happy to be back, and we're really going to start by talking about security and by talking about performance. Now, these are the two meat and potatoes, which Bob has talked about a few times. And I think you'll find that Bob's hyper-focusedness, just making
Well, that's
that
a
word
new word,
longer and longer,
hyper-focusedness. Yeah, exactly.
is going to come through and through in this. We've got lots more demos for today. We hope that you've been able to try some of the exercises in Microsoft Learn. If not, they'll be there this afternoon, tomorrow, next week, next month for you to try and learn more. For those of you that might have not been with us yesterday or are needing a little bit of a refresher, we are joined by many moderators from the Azure SQL product group who are there to answer all your questions. We got a lot of questions yesterday, and we're really grateful to our moderators and their great work at answering those questions. And I also wanted to give a thank you to the Microsoft Learn team, and especially Rob Gibbons for his help on all these efforts. He's the one working everything behind the scenes, making all of this possible. If you do want to ask questions and you're not sure where to do that, depending on the size of your YouTube browser, it'll either be on the right side of your screen next to the video or underneath the video, and you can just comment there with any questions or comments that you have. I mentioned Microsoft Learn because all of this is related to a Microsoft Learn learning path called Azure SQL Fundamentals. Now, this is something you can use to get free hands-on lab, which means you don't need an Azure subscription. You basically get time-box labs. So at 4-hour increments, you can play with Azure SQL and do a bunch of the exercises that you're going to see today as demos. So we hope that you do that either now or later or sometime even in the future or with your friends or whenever. So without further ado, let's go ahead and start by talking about security. Now, what you'll see as we talk about these meat and potatoes is we'll first talk about the capabilities. So what's possible, what's in Azure SQL, how is it different from on-premises, and then we'll talk about the tasks. So the tasks you're very familiar with doing, how do they translate when we talk about Azure SQL? So in this first meat and potatoes section, we're going to talk about capabilities like Azure Active Directory. We're going to talk about RBAC, auditing, different ways of encrypting your data, whether it's in use or at rest, and data masking or protecting sensitive data, and kind of how you can package that all together using auditing, classification, and a few other new things to Azure to really get more out of it and more understanding of who's accessing your sensitive data. And then we'll do some interesting demos around advanced data security, which is something that is mostly only available in Azure SQL today. There's some caveats to that, things we're working on. And then once we talk about the capabilities, we're going to talk about the tasks. And, before we get into it, Bob, you spent a lot of time with security over the years. Can you start by kind of telling us what stands out to you?
Sure, thanks, Anna. If you look at this slide right here, it's very interesting because if you'll notice at the very bottom of the slide, we have what we call breadcrumbs, and it's a way of organizing this content into categories. And if you think about enterprise class security for SQL Server, it involves these four areas: network security, identity and access, data protection, and security management. And what I love about this module we're going to do today is that you're going to find a lot of things very comfortable to you today that feel like it is SQL Server, using T-SQL or various tools that just look like SQL Server. But just like in your infrastructure, you need things to manage and set up security for SQL in the infrastructure, and we have that for Azure. Keep in mind that whole Azure ecosystem that we talked about and how we're going to snap security into that. And then finally, there's got to be some reasons to move to the cloud, right? There's got to be some benefits that Azure is going to give you for value-added services. And so in the management section, you're going to see a few things that are very unique to Azure and things that give you additional capabilities because of the fact that you're playing the Azure ecosystem. So what you're going to see now is myself and Anna go through these categories. We're going to talk about network security. We're going to show some visualizations and some demos. We're going to talk about authentication a little bit. We're going to get into some data protection with encryption scenarios. And then finally, we'll conclude with some management situations, including auditing and things like what we call advanced data security.
Oh, thanks, Bob. And with that, we're going to get right into it and talk about network security. Now, Bob and I went back and forth about how much we should cover network security here, because at the end of the day, a lot of SQL folks also have a networking team or networking gurus, but we felt it was really important for you to understand on a fundamental level what the differences are specifically for Azure SQL Database and why you might choose one over the other. Now, the first option, we're going to go from what we might call as least secure to the most secure. Now, that first option is allow access to Azure services. Now, what you're seeing here is basically, if we take a look at what's on the page first, let me grab my pointer. We have some virtual machines which might be trying to access an Azure SQL database or an Azure SQL database logical server. Now, what those Azure virtual machines are able to do with this allow access to Azure services, which is simply just a checkbox, is they can access any Azure service, can access the Azure SQL database logical server if it has the credentials to do so. From a networking perspective, though, it's not blocked. Now, what you can't do with this is on-premises is not really able to access that because, as the name suggests, it's just Azure services. So the next option you have is firewall rules. Now, you could use this in conjunction with the previous option, but if we look just at firewall rules, what we would have to do is create a firewall rule from this logical server for each virtual machine or application or any service really that's going to access this database. Additionally, we would have to create firewall rules from on-premises. Now, this is great, but this could be challenging. For example, many customers have dynamic IP addresses, meaning their IP addresses change. And many applications have lots of users that might be needing to access this data. So you don't necessarily want to be able to keep track of all these firewall rules. It can get very cumbersome very quickly. So the next option that you have is a virtual network rule. And what this basically means is these three boxes are all different virtual networks. You can see what region they're in as well. And basically, you can, instead of adding individual firewall rules, you can add a virtual network rule. And that basically would apply to everything within a given virtual network. So actually, by using this setup that you see here, I can just allow access to this virtual network. And then I can use other virtual network and networking capabilities like virtual network peering to connect these virtual networks using virtual network gateways, VNet to VNet. Even if you have something like ExpressRoute to your on-premises environment, as long as you have access to a virtual network that has a rule to the database server, you're going to be able to access it. Now, there's one thing that happens else when you do this that you don't get with firewall rules. So I'm going to flip back to firewall rules, and what you'll notice is from the database server, we're going to be picked up as accessing from the public IP address of the application or the virtual machine. Now, when we move to virtual network rules, what we get is we're now connecting from the private IP address of those virtual machine or application. So this gives us a little bit more security. But what you'll notice is over here, I have some results of an NS lookup or the DNS hierarchy. And from that, so anyone can kind of see where this database might live, as well as the public IP address associated with this. So this was a big concern for customers, not just for Azure SQL Database, but really all Azure services. So over the past year or so, we've been introducing something called private link or a private endpoint. Now, this is available in general availability or GA for Azure SQL Database today. And what this basically allows you to do is create a private endpoint associated with a logical server. Now, in doing this, what you do is you make it so that the only way you can connect to this thing is through that private endpoint. And so this is going to make it a little bit more secure. There's actually a typo in here, but I'll show you in a demo of what the resulting hierarchy is. But what you'll notice is from virtual network rules to private link, I didn't have to change that much. It's still kind of the same principle. It's basically now, instead of needing access from the database server, you just need access to the virtual network where the private endpoint lives. And setting this up is quite easy. You can even have multiple private endpoints per a database server. And there are some reasons why you might want to do that. What I thought would be useful, and also if you do have private endpoint, you have this option to completely shut off access to the internet, to the outside internet, which can be useful depending on your scenario. But what I wanted to do is just show you a little bit of how this looks in a demo. And if you go to our GitHub page, you'll actually be able to see all of this, all the demos that I'm doing here, and you can try them yourself. So what we're doing here is I'm in SSMS, and I'm basically running this command, which is going to tell me from what IP address I'm accessing the database server. So this is the public IP address of this virtual machine. As you can see, it matches that public IP address right there. So here, what I'm using is just firewall rules. So I just have a firewall rule allowing access to this virtual machine, and that's going to connect from the public IP address. Now, the other thing I can do is I can run an NS lookup, and this is just going to show me the DNS hierarchy. So I'm looking up that server, and what you're seeing is a few things. This IP address is specific to Azure, but what I'm also able to see is some information about that database server. So I can see it's in control ring 4, it's in East US 2A. I can also see the data slice and a few other things, pieces of information about it, as well as a public IP address. Now, many customers, many folks don't want this to be so publicly accessible to see this DNS hierarchy. So what you can do is enable private endpoint. Now, what I have in the portal is I went ahead and created a private endpoint for a different server. The other server is actually my DR server, and this is just my regular server where I have private endpoint enabled. And you can see it has a private IP address associated with it and a FQDN. Now, one important thing to note is once you move towards private endpoint, if you're already set up for virtual network rules or firewall rules, you don't have to change any connection strings. You're still only connecting to the same FQDN, and that won't change, and you actually cannot connect directly to this private IP address. So now if I switch back to SSMS, can run the same query, except this time you can see that I'm connected to the non-DR server. And what I'm going to do is just run that. And you'll see now I'm getting this other client net address 10.0.0.4. But what is this? This isn't the private IP of my private endpoint, because recall, this is pulling what we're connecting from. So this means we're connecting from the private IP address of my virtual machine. So no longer were we connecting from the public IP address. Now, the final thing I wanted to show you is this DNS hierarchy. So recall before on the disaster recovery, which did not have private endpoint enabled, we're able to see a lot of information. Now, if I run the same command on this other server, which does have private endpoint enabled, what I'm going to see is something quite different. So I'm still seeing that we're coming from Azure. And what I'm seeing here is now we're going to the server name.privatelink.database.windows.net. And in the aliases, I'm not really seeing any information about this database. No public IP address. Again, this is the private endpoint we assign to the database. Nothing about the location or the control ring or any other ways of accessing that database. So this is just hopefully a quick demo to show you some of the benefits you get by enabling private endpoint. And now we've talked about this for Azure SQL Database, and you might be wondering, okay, well, is it different for Azure SQL Managed Instance? So this is our SQL Database view. Now for Managed Instance, it's a very similar concept. There are some specifications around the Managed Instance subnet that are required in order to basically deploy a whole ring for you inside a Managed Instance subnet. But basically the concepts around setting up connectivity are the same, except now you're going into a managed instance that might be in a managed instance subnet. And you can see they do have these private IP addresses associated with that. Now, as you look at these options, you might be wondering, okay, you showed me a lot of options. How do I kind of decide what to do? And
Yeah.
Oh, sorry. Go ahead, Bob.
No, Anna, I mean, actually, I love the description of what you did there, because we really debated, a lot of how should we present this topic. We feel a lot of people doing SQL Server are not necessarily network experts. I know I'm not. But if you break down the task and how you would do what you just showed for Azure SQL Database, I think you made it very clear to us that if you want to be as secure as possible, you would configure private link as much as you should, right? That would be like your first choice. There could be some reasons you can't do that or don't want to do that. And if that's not possible, what we recommend is to turn off allow access to Azure services. Let me pause for a second and just say that if you're just getting up and running quickly, I do this all the time in Azure, and I know you do this. If I want an Azure VM to connect to my Azure SQL deployment, I actually turn this on just as a proof of concept. But for a production scenario, we recommend turning that off. And if you can't use private link, then you're going to use one of two things. You're going to configure firewall rules specifically. Maybe that could be for on-premises scenarios if you can configure that IP address, or use this virtual network rule concept. Now, just keep in mind, though, on that right side there, though, you still have a public endpoint for your Azure SQL Database deployment. But like in the case of the virtual network rules, it's going to be an easier way for you to set up, because you don't want to rely on static IP addresses. So that's the database side. For managed instance, remember, we're building that ring for you, that cluster, so you already get a virtual network and subnets in this process. Now, here's the rub. When you deploy managed instance, say like through the portal, you can pick this virtual network option, and Azure, our deployment, will set up everything you need. But it is possible that you already have a virtual network you want to connect this into, so you can do it before you deploy managed instance. But there are some very specific rules for setting up the subnet and all the different permissions that you need to do. And so we document all that stuff. You can do all that stuff in the portal, and you can see all the options. Now, I should also mention there is an option here as well to get up quickly to do a public endpoint in managed instance if you'd like to do that. And in those particular cases, you'll be using what's called a network security group rule to set up access to get into a port, which is not the port 1433, it's a different port to access managed instance. But notice on the screen right here, we really recommend for production enterprise scenarios that you work with your networking team, because they're used to doing a lot of these things. They understand virtual networks. They understand making sure you have the right firewall rules and ports access and so forth. So, we wanted to give you enough knowledge to be very educated about this, to understand how to do it, how to get the speed very quickly to connect, but also understand what we recommend is possible for you, and then to work with your networking team to go farther.
Yeah, definitely. And we'll put this question up, but I also just wanted to check and see if we had any questions from the audience to talk about. And we'll just wait and see if those come in. And while we wait for that, I can go ahead and talk to you about these knowledge check questions. Now, recall from yesterday, the way that we're doing this is we're going to have you answer both questions in one comment. So for example, if you thought A, then A, then you can go ahead and just put AA, for example. Now, the first question is, what is the recommended way to protect your network for Azure SQL Database? And the second gives a slightly different example, similar to the demo, that considers the example from the unit and what is going to be the results if you have virtual network rules enabled when you run that SQL query below. And while you guys are answering those questions, I'm going to go ahead and we'll talk about a few questions. So the first question is from Michael C., and he says, can all of these options be used with Power Apps to connect to Azure SQL? Now, from my understanding, it's going to depend if private link is available for Power Apps, which I honestly don't know the answer to that question. But many of the Azure services, just from my experience, do require either allow Azure services to be on or some sort of virtual network rule. Is there anything else you wanted to add to that one, Bob?
No, I suspect that actually probably works. One thing to be clear about allow access to Azure services, that just means you're giving permission for any Azure services to connect to your Azure database. It doesn't mean you still can't use virtual network rules, right? So that allow access to Azure services does not have to be on to do a virtual network rule. The private link, you're right, Anna, we need to confirm that one and double check. I suspect it does work, but for sure you can do a virtual network rule within the Azure infrastructure.
Yeah, and it looks like there is some clarification saying that it does work for Azure services today, but not sure if it works with private link. And I would say if it doesn't work with private link today, it's something we're investing in because that is a very important effort for us.
Absolutely.
So thank you, Michael C. Now I'm going to take a look at the chat and see what answers you guys are saying for the questions. So it looks like a lot of D, A, and D, B.
Okay.
Mostly that seems to be
what are the ones everybody's saying, Anna?
D for the first one. So okay. The recommended way to protect your network for Azure SQL Database is private link. So that's good. People are paying attention. Okay. And for the second one, I was seeing mostly Bs, but some As.
Okay. Should we go through them a little bit?
Yeah, let's go through them.
Well, look at the first one. It's a tricky question, right? Because you could say, for example, virtual network rules. Let's pick on that one. That could be a recommended way to do this, right? Because it's an easier way because you don't have to know IP addresses, but it is not the most secure. So if you think about from a recommended to protect your network, that was the key to the sentence there. Firewall rules, allow access to Azure services. Those all still use public endpoints, right, Anna? So, and in fact, A, we just talked about is a fairly least secure option because it means anything that anybody gets in Azure can access that public endpoint. So D makes sense because it is the recommended way to protect the network for the Azure database in the most secure fashion. So for the other one, this is based on the demo that you did, right? So you're using virtual network rules in this case. You're not using firewall rules. You're not using allow access to Azure services. So in this particular case, since you're inside a VNet, the public IP address of the client would not apply, right? And since A doesn't apply, C doesn't apply, and D doesn't apply. I always do the elimination. That's how I took tests. That's how I took tests in college. So B, would have to be the right answer here, right? And you showed that. You showed the fact that if you're in a VNet, you used a private link, I think, in your example. But if you're in a VNet as well, you're going to have your Azure VM or your client that's going to use that virtual network private IP to connect in. And that's what's going to show up in this DMV because the client net address is the IP of the client connecting into the Azure SQL database.
Yes, exactly. Thanks, Bob. And thanks everyone who's participating in the chat. We got a lot of answers, so that's awesome to see.
Good. Anna, we talked, remember, about the Azure ecosystem. And again, think about you need access to resources in your infrastructure in your data center. How do you do that? You're a SQL admin, right? Somebody's got to set up to you an account, correct? You need a domain account. You need permission to do something. So in Azure, you have the same concept. you need some sort of control or access to what? Deploy Azure resources, like deploy in the portal, deploy a database, a managed instance, to go manage these things like the network scenarios that you just talked about. So Azure provides something called role-based access control, which is based on a subscription or account, but it also can be set up from a role perspective. And there are some built-in roles. So for example, you could be the owner of your subscription and you pretty much have access to anything you want. You could be what's commonly known as a contributor. Contributor is very popular. In fact, Anna is a contributor on my subscription. I have to kind of watch her a little bit every once in a while, right? But I give Anna permission as a contributor to deploy resources for Azure in our subscription that we use together, right? So what it does is allows kind of a separation of duties between what you're doing inside SQL Server and outside SQL Server. And the role-based access applies both into the using things in the portal and for command line interfaces or APIs. So if you're using the Azure CLI interfaces or using the portal, this RBAC system is what you're going to be using. And so one thing we've done to kind of help you a little bit get started, if you want to set up your own type of roles to allow certain subscriptions in Azure to do things for database or managed instance, we have some built-in roles. And you look here, for example, if you're a SQL DB contributor, you have access to then in that subscription deploy Azure databases. But maybe you don't have access to deploy virtual machines. Like, you can control then a more fine-grained idea of what you can do in Azure, what you can't do in Azure. So we've had built-in roles we've provided that you can add people into those roles from subscriptions, and it gives them access to do certain things. A SQL security manager gets to do security operations like perform auditing and so forth, but they can't necessarily deploy an Azure SQL database. Just to be clear though, this does not imply access of what you get to do inside SQL Server. So I think it's important we talk about that as well. So think about authentication in SQL Server today. What do? Well, one of the very first things we see in Windows for SQL Server is the mode of authentication. So in the default setup for SQL Server today on Windows, you have what's just called integrated security, right? Or Windows authentication being forced. So you have to have a Windows account to log in. But you can set up in SQL Server what's called mixed mode, and you have to restart SQL. We force this for SQL database and for managed instance. So, and we do that because when you deploy an Azure SQL database or managed instance, you have what's called a server admin. And for SQL authentication, we have to force mixed mode, otherwise you couldn't log into SQL Server. As it turns out, that's mapped into a server level principal for the logical server for all the databases in the server. So think of that logical master. So you've got the server level principal that really has access to do anything they need to do in the logical server and all databases for that server. So for example, the server admin, when they create a database, becomes the database owner of that new database. And then in managed instance, it's going to feel like a SQL server. So the sysadmin server role, this server admin, again, you provide this when you deploy through the portal CLI, it becomes a member of the sysadmin server role. Now, you might want Windows authentication scenarios or integrated type security. And so this is where Azure AD authentication comes into play. So if you think about what you're doing with authentication with managed instance, you can now go and set up, in addition to this SQL auth server admin, you can set up an Azure AD based server admin based on an Azure Active Directory account in your organization. This implies you've set up Azure Active Directory, and there's a process that we document how to do that for your organization. Now, from that point forward for managed instance, you can create logins and users like you used to in SQL Server. Those logins can be SQL based or Azure AD based, just like maybe a Windows login would be based. Then you would create users in your database and map them to these logins, just like you would do in a SQL Server. Now, we do support the actual contained database concept. So if you want to go down that path, you could do an actual container-based and managed instance. Well, what about Azure SQL Database? How does that differ, or is it the same? You also have the ability to do an Azure AD server admin, which again is a server level principal for your logical server based now this time on Azure Active Directory. You can still do SQL logins as well if you'd like to still do that process. And you also have database users. Now know that you have something a little bit different in Azure Database for this logical server concept. You have specific roles for users in that logical master called Login Manager and DB Manager. And you can actually put users in there, and they're kind of limited server admins to help deploy databases or to add additional logins. It's something we've added for Azure Database because it's not a full instance of a SQL server that you're actually accessing. Now, what we recommend doing in Azure SQL Database, though, is to create contained database users, and specifically using Azure AD. So imagine you creating an actual user in a database without a login mapped to an Azure Active Directory user. That's very, very powerful now, because people will just connect in, and even if necessary, could do a seamless Azure AD login to their environment, wherever it is, and then just connect right in to the Azure SQL database. So that's kind of the process to set up authentication for Azure SQL.
Thanks. Now, we've talked about the capabilities, and now if we think about the task, what are you going to do? You're going to deploy with a SQL Server admin, and then once you deploy, you can create other admins, including an Azure Active Directory admin. Then those admins, admin or admins, can create users, and then you go about granting access just like you would in SQL. And that's something we like to harp on too, is when we say it's just SQL. This is a great example of that. So now let's take a look at what that looks like. So I'm going to hop back over to my demo box. And in the portal, I have this logical SQL Server for Azure SQL Database. Now, on the right-hand side, and I can make this just a little bit bigger. On the left-hand side, sorry, what I have is lots of information, but one of those things is the Active Directory admin. So if I click that, what I can do is I can go ahead and set an admin. Now, this is a pretty easy process, but it's good to note that you can only have one user or one role as an Active Directory admin. So I'm just going to go ahead and add myself, select it, and hit save. Save is an important piece, otherwise it won't be saved. Now, once this is saved, and it just takes a few moments usually, I can switch back over to SSMS, and I have this other script, and I'm just going to connect using Azure Active Directory. So you see there are a few options here, either password, integrated, or universal with MFA. So I'm just going to go ahead and connect using MFA. It might call my phone, but I did this earlier. So now we're connected. So now what might be something I would do just like SQL? Well, I might create a SQL user and give them a password. Now I can do this, but note I have to be in the context of master in this case. Now I can switch to a database and say I want to create a new SQL user from that database. So that's what this command would do, that create user. And again, this should look very similar. Now, until I give them either DB data reader or DB data writer, they won't have access to read or write data. So this is a pretty simple standard example. Now, we talked about a little bit about, Bob talked about contained database users. So now what I can do is I can actually create a user with a password in the context of the database. So I don't have to create a login for them first in the master. Now, Bob, with a password for Tannehill 1, because he loves the Tennessee Titans, can log in only to this one database that we have. And finally, this is something that's a bit different from what you might see on-prem, is if you want to create other Azure Active Directory users, you use this new syntax called from external provider. So I can run that in order to give Bob access from his Azure Active Directory account. And similar to before, he still won't have access to read or write data until I give him that access as well. So this is a really simple example just to show you how it's mostly just SQL, but a few things do become slightly different. And this is one that you can also find on our GitHub page.
Looks like we have a question, Anna, we probably want to tackle here before we go to the next section.
Let's take it. So is it showing?
Here, I'll show it.
Awesome. So Hassam asks, what if my application is authenticating to SQL using Kerberos? How can it authenticate to Azure SQL Database? Is my choice only to refactor my application to connect to Azure AD?
Yeah, so if you think about today, you're using domains, right? Typically with Windows. So you're actually logging into a domain user account and then you're using your application to connect in. So yes, you're going to need to use Azure Active Directory in this case for Azure SQL Database. That's effectively your Kerberos option to connect in. And then Anna just showed you some of the options. There's an integrated option, there's a password option, then there's an MFA, a multi-factor authentication option as well. So that is true that that's going to be the process to connect in, and that's how you're going to get Kerberos authentication.
Awesome. Thanks, Bob.
So we talked about identity authentication. Remember our breadcrumbs down here, right? We're kind of following along. We did network security, identity and access. Let's talk about protection, which usually relates itself in terms of encryption. So if you think about encryption, there's a connection encryption option. There's encrypting your data, encrypting at rest. There's even a concept called always encrypted. So note this about encrypted connections, that we force this both for Azure SQL Database and managed instance, and we're using TLS. So even if you don't select an encrypted connection on your client app through SSMS or something, we force this. Now we recommend you do it though, because it actually avoids a negotiation. It's going to be a faster connection. So we force that. And in addition, this is actually fairly recent this spring. We've offered an option for you can specify the minimum version of TLS you'd like to use. The latest versions are a little more secure. So you can even force that applications use a specific version of TLS as minimum to Azure Database or managed instance. Now we do common level encryption just like we do in SQL Server. All those encryption options are there. Transparent data encryption is an interesting one. So we're going to put this on by default for your database for Azure SQL Database and managed instance. We think that's the most secure way of encrypting your data at rest inside the Azure infrastructure. So be aware of that when you're deploying databases. You can turn that off, but we do certainly recommend that. That also allows us to do other things in the backup space to make sure things are encrypted there as well. Always encrypted, a popular feature that we announced in SQL 16 and enhanced in SQL 19. This is an end-to-end encryption scheme, allowing your data to be encrypted and avoid things like man-in-the-middle attacks. And we fully support this with Azure SQL Database and Managed Instance. And we even support the ability for you to bring your own key and use managed keys with Azure Key Vault. That applies to any of these encryption scenarios. If you want to, don't use our service manager keys, although that's very secure. We do certificate rotations, all the things you'd expect from keys. You can actually come and bring your own key and use things like Azure Key Vault to make that integration point. Always encryption is an interesting feature. You have things like deterministic encryption and randomized encryption. That's kind of important to go decide what to choose in this Azure SQL scenario, because deterministic encryption is where you're going to get things to support like operators like join, group by, distinct, those kind of type things. Whereas randomized may not support those. So you have all those kind of options to pick when you're encrypting your data. But again, the beautiful thing about always encrypted is that it's a separation of duties concept. So the data is encrypted, the application controls that encryption, the unencryption, and database administrators are not allowed to see the actual encrypted data itself.
Thanks, Bob. And one question that we get a lot that I thought I'd bring up is, what about secure enclaves?
Yeah, secure enclaves is a new concept that we introduced in SQL 19, and we're not yet ready fully to support that in Azure SQL Managed Instance and Database. You can do it in Azure VM. Enclaves are supported both from a virtualized point of view and at the hardware chip level. And that's a technology we're very excited to work on. That allows, it's very interesting because that kind of opens up the query pattern set that's allowed for queries against encrypted data. And it also allows us to do unencryption at the server itself within what's called a secure enclave. So stay tuned for that. We look forward to kind of introducing that concept both for Azure SQL Database and Managed Instance.
Thanks, Bob. Now, as we continue to talk about data protection, there's this concept called dynamic data masking. And this is a SQL concept. This exists in SQL Server today. And basically, the idea is that not everyone should be able to see sensitive data. So you want to be able to mask data to specific users or roles that should not have access to it. But you also want to unmask data for roles or folks that do need to be able to see that data. And you see from the syntax that you can set this up for specific columns in a table, and there are different functions that we have available. There's just a few examples on the screen, whether it's a partial mask, an email mask, or a random mask. And you basically do this by adding masked with, and then you can grant unmasked to specific roles. So in this case, we're doing it to the role of data officers, which might contain some users that do need access to that data, like the email addresses, but from everyone else, they will not be able to do this. And in the exercises in Microsoft Learn and on GitHub, you'll actually go through this process of giving Bob access, then taking Bob's access away, then giving it to him again, and just really messing with him. And then we have a whole thing where you'll actually audit that and use data classification, which we'll learn about shortly. Now, one of the things you get in Azure SQL is we can actually recommend the fields that we think you should mask. So that's something kind of new that you can do from the portal. And you can use T-SQL or the portal to add other masks as well, but you're also going to get these recommendations. So as we kind of think about the capabilities around data protection and we think about the tasks related to that, you really want to ensure that your applications are forcing this connection encryption if possible. That's going to help make it more secure. You're also going to want to evaluate your use of TDE. As Bob mentioned, this is turned on by default for new databases, but if you migrate, this might be something you still need to consider if you should turn on. We talked about dynamic data masking, and if you really want to go the extra mile as far as you're encrypting your data, that's where always encrypted or things like BYOK can be really useful. Now we'll take a second and we'll look at questions if there are any that are in, and we'll also do a quick knowledge check. So the questions are, how can you manage who has access to view mass data? And this second one, this is tricky. I'm not sure we actually covered this question.
Anna, you are tough. I mean, I covered it, but it's not like I, waved my hands when I did it. So I did talk about it in fairness, but you tough, man.
So we'll see if folks get this one. It says, when doing equality comparisons on encrypted data with something like always encrypted, which operators are currently supported in Azure SQL?
You certainly are going to see people paid attention, that's for sure.
So let's see.
What's it looking like there?
It looks like we're getting, I haven't seen anything apart from B and then D.
B and D? Okay.
Looks like B and D.
People are doing B on number one. Okay.
Yep, that's all we're seeing. So let's go ahead. Bob, why don't you take a stab at these questions?
Well, through our normal process of elimination, we think about how can you manage who has access to view mass data. That's the key part, manage who has access. There is a mask, if you look at D, there's a masked keyword. That's how you do masking, right? When you create a table. So that's not going to control who has access. That's just going to control what the masking looks like. So let's throw D out. Anyone who queries mass data can view mass data. That's not true because that's the whole idea of masking, right? You run a query against mass data, you can only view it if you've been granted access to that. And then it says, number A is you can, only server admins can view mass data. That's not true. The whole purpose of this feature is to grant people, specific people, access to view data. Therefore, B, using grant or revoke, is the way to go manage access to view mass data. So I would say B.
Yep.
On the second one, way to go, Anna. I mean, I did say in there that with always encrypted, with deterministic encryption, you can do joins, group by distinct operators, and so forth. And so all three of those apply. D is the right answer. You should know, though, that it's a fairly good study. If you're going to use always encrypted, take a hard look at what you can and can't do, because there are some operators that are not possible depending on how you pick your encryption scheme. And enclaves are one thing that we do to kind of open up some scenarios. But D is the right answer there.
Awesome. Thanks, Bob. And it looks like for the most part, as these answers have been rolling in, as you've been talking, most people are saying B, D, and a few people have said for D, trick question.
It looks like there is a question, Anna. I'll show it for you.
Awesome. So Mickey says, regarding dynamic data masking, does this automatically carry over to a read-only replica?
Okay, Anna, do you want me to do that, or are you going to do that one?
You got it.
I always get that from Anna. You got it. So I will give you the answer by teaching a concept, and that is if something is inside a database, right, inside the metadata of a database, and you use an always on availability group, or in the case of business critical, a replica, that metadata is inside the database. So the answer would be yes, it carries over because you're defining your masks inside the database. Now, there are some features like query store, which are inside the database. that can't be used in a replica, at least today, because we have to write to that data. So it is read only, but yes, a mask would be carried over because it is inside the metadata of the database.
Awesome. Thanks, Bob. Thanks for that lesson. I appreciate it.
I mean, I didn't even look that up. I mean, I'm just telling you that's got to be the case because of the fact that inside the metadata of the database. So.
Awesome. All right. I don't see any more questions here. So we're going to continue onward to talk about security management, and we're going to start with auditing. So first, I just wanted to call out that you can audit the Azure level activities with the Azure Monitor logs. And this is something you'll do in the hands-on exercises. So you'll kind of get a chance to look at how you do that. And even throughout the exercises, you'll also get to see things like Azure Monitor and Log Analytics, which are kind of new, rich capabilities that allow you to look at different things in a different way with Azure SQL. Now, the next thing is SQL Server Audit. Now, this is used for Azure SQL Managed Instance. And the great thing is that it works just like SQL Server, except the storage is Azure Blob Storage for those XEL files. Now, there's a few exceptions to that. For example, you can have failure or continue options, but no shutdown. And this makes sense because we can't have you doing that with your managed instance. That would interfere with our SLA. Now, when we talk about Azure SQL Database, it's slightly different. This is called Azure SQL Auditing, and it has some default action groups, including batch completed group, successful database authentication group, failed database authentication group, but there's no exact audit level audit action group equivalent. Some of this is available through things like the activity logs, which you'll get a chance to take a look at in the hands-on labs, as well as the batch completed group default action group. And one of the other benefits of Azure SQL is that there are some different places, like I mentioned, where you can actually store and analyze these audits. And in the exercises, you'll take a look at how you can use log analytics to see what sensitive data, for example, Bob has accessed with that dynamic data masking or that sort of thing. You can also push it to a storage account, which you'll see in the exercises as well, and with Azure Event Hubs in preview today.
Yeah, and if you think how you're going to put this together, you just talked about the auditing, which is extremely important when you're looking at securing your assets. The first thing that you think about, and maybe in your SQL Server environment, at least your company does, is how do I audit things outside SQL Server, which Anna just talked about. So remember the Azure ecosystem. We talked about activity logs, like monitoring deployments. Well, it turns out anything you kind of do outside SQL in this Azure ecosystem is captured in activity logs. So you can use activity logs, and by the way, you can set up permissions who gets access to that. So for example, if you want to audit who's doing RBAC role scenarios and setting those kind of type things up, all of that's available in activity logs, all available in Azure monitoring. What about for SQL itself though? So for Azure SQL Managed Instance, the first thing you're going to consider doing is you're going to configure SQL Server Audit for Azure SQL Managed Instance, just like you configure SQL Server today. But remember what Anna talked about is the fact that when you configure that, you're going to be using Azure Blob Storage. Remember, these are extended event files for SQL Server Audit. So you don't have access to the local file system. So you're going to be, and we have all the documentation to show how to do this, you're going to be using Azure Blob Storage for that. But she also talked about a few other options which are interesting for things like Event Hubs or Log Analytics. Now in SQL Server, since I've been at Microsoft, in the error log, we've always tracked failed and successful logins in SQL Server. You get the failed login scenario. So by default, if there's a failure for a login, you can look at the error log for managed instance and you can see that. You can't get successful because the default's failed, and you can't change the default for success and fail because you have to restart SQL Server. But Xevent is your friend. You could actually use a separate extended event session to track successful logins. Now, Azure SQL Database, as Anna mentioned, it is powered by SQL Server Audit, but you don't use the normal interfaces for SQL Server Audit. You're going to use Azure interfaces like the portal or CLIs. So you're going to configure this. And as she talked about, this whole idea of groups and so forth and action groups are still all there for you to configure. Now, in addition, when we built SQL Azure or Azure SQL Database, we wanted to give you some additional things from a DMV perspective. So there's something called Event Log, and in there you can track metrics like number of successful or failed connections, number of people blocked by a firewall. And because of the fact that it's in these metrics in this event log, we expose that through Azure Monitor or Azure Metrics. So you get that information inside your Azure logical server, like in the master, or you get that outside of Azure through the portal or looking at things like Azure Metrics or Azure Monitor. And then finally, one of the things you're going to do to manage security is set up things like alerting, not just the alerts we talked about here for audits, which you can do, but we're going to talk in a second about something called advanced threat protection. So you're going to set up alerts for those kind of things. And we'll show you in a small demonstration in a second. You're going to want to monitor something called the Azure Security Center, which you're going to love, a complete package of what's going on all across your Azure enterprises. So let's talk about a concept called advanced data security. That's a term we've coined, and it involves these three areas. It involves data discovery and classification, vulnerability assessments, and advanced threat protection. Let's talk a little bit more about advanced threat protection, and we'll show you a demonstration of what these other two are as well. So when we were first building Azure SQL a few years back, we wanted to provide value-added services in the cloud. So therefore, we decided to go build a concept called advanced threat protection using a concept of machine learning algorithms, monitoring what's going on with your deployments and deciding to help you, can we alert you to certain things going on with your deployment? Something you'd have to build yourself. So imagine today in your environment, you having to monitor SQL injection attacks, people running queries against your database, trying to do SQL injections through an application. Like, how would you do that? How would you build a system to go figure that out? How would you remove anomalies that maybe really you shouldn't be alerted to, but some you really want to be alerted to? So we built this idea of advanced threat protection, and we made it a value-added service for the cloud. And it's available today for Azure SQL Database Managed Instance, and we just started doing this as a preview in VM. You're going to see us continue down the path of offering services like this in other assets like Azure Arc. So, and I thought it'd be kind of cool to go show a demonstration of what these advanced data security features actually look like and why you might use them.
Yeah, I think that would be great, Bob. And then when you're done, we got a really awesome question.
Uh-oh. I hope I know the answer. Yeah, if you think about what I just talked about, we want you to feel like the cloud, besides all the great advantages we talked about the cloud, and we're going to talk about more, are there things in security that I can get because of the fact that you've deployed on our infrastructure? And you're looking here at the Azure portal for a database I've deployed, and I'm showing you under advanced data security right here, I'm showing you these three concepts of data discovery and classification, vulnerability assessment, and advanced data security. Let's just briefly look at a couple of these. So data discovery and classification, perfect for GDPR scenarios. You would like Microsoft to look at the columns of your database and help label and tag these, and then go query later at the metadata, how many columns are marked as GDPR? And not just that, I'd like to audit access to anybody touching this. And if you go to the Learn Labs that we have, we're going to show you how to go do this. How do you go classify it? How do you go run queries? And then how to use that auditing feature to go back and look and see who tried to touch that. So that's a great example of classification. Vulnerability assessment's an interesting one. We said to ourselves, we have knowledge within the SQL team. Like, we know how to go look at the configuration of your deployment and decide, are you vulnerable to certain types of security problems? And so we use industry CIS benchmarks to go out there and decide, how can we build a set of rules? And again, since we're in the cloud, we can actually modify these rules, add to them and enhance them, and flag for you possible risks. Now, the other thing I love about this feature is you can go to a given type security check, like, hey, the DBO user shouldn't be there for normal service operations. And you can decide, I'm going to go look down here at the query we're running to see what the rule looks like. You can even run it in an editor. You can see more description about it. But let's say you decide that's okay for my environment. You can approve it as a baseline, and then we won't flag that in the future. So that's vulnerability assessment. And then the last piece is what we just talked about, advanced threat protection. Now, again, this is us using machine learning algorithms and tracking what's going on, not your data, but access to your deployments, and giving you recommendations about things that might have occurred. So you can see here that's really interesting. I can detect problems that are going on from people trying to connect in, do brute force attacks, or what's really interesting is SQL injection attacks. So I can look here that somebody tried to run a query that kind of looked like an injection. And if you've ever seen this concept before, you can see the query that's right here kind of looks like somebody's trying to run a string that may inject something. I love this concept. And then finally, to top it off, if you want to kind of see overall what might be going on in your environment, you can go over and look at something called the Azure Security Center. Let me get this up right here. Right here. The Azure Security Center is amazing. This is an overall look. Let me kind of zoom down a little bit so you can get a bigger picture. It might not be as visible in your screen now, but can you see this dashboard? I can see compliance, hygiene of all my resources, and threat protection. And this is across every resource in Azure, not just Azure SQL Database. So Security Center being this really cool hub of looking at security for my entire deployment.
Thanks, Bob. That's a really awesome, cool demo. I love that one. In the hands-on, you'll actually get the chance to trigger one of these yourself and see what happens and see how fast ATP is able to pick these things up. Now, before we get to the knowledge check on the board, Adam has a really great question. He asked, has Bob ever auditioned for Who Wants to Be a Millionaire?
Well, I need to learn how to phone a friend, right? So I think before I do something, if you go, real quick funny story, if you go on YouTube and look for this with Who Wants to Be a Millionaire, there's a famous one on YouTube where a guy phoned in his dad at the very end for the last question, but he didn't phone his dad to get an answer. He said, "Hey, Dad, I just want to call you, let you know I just won $1 million," because he knew the answer. Then he gave the answer, and then he won $1 million. So anyway, that's a fun one to watch. So that's pretty funny, actually.
But so you haven't auditioned to be?
I have not auditioned. No.
Maybe you should consider it. It seems like Adam thinks you'd be a good contestant.
Because I can do elimination, right? So
that was a fun question. Thanks, Adam. So as we look at the knowledge check and we wrap up this unit, I wanted to ask which of the following T-SQL for auditing is not, so this is again, is not supported in Azure SQL Managed Instance.
There you go with those not questions again. Good grief.
And then the second question is, which of the following are ways that you can monitor security-related events for Azure SQL Database? So go ahead and put those answers in the chat. Let me see.
You should not say not next time. Just say the question.
Yeah, you're right. I shouldn't emphasize the not.
You're making hard questions, but you are helping the audience. It's okay. We need to help the audience.
So it looks like I'm getting quite a few D's and D's. So D for both answers.
D's and D's, okay. D's an easy one, right? D. Looks good. Great
now,
server.
For those of you putting D for question 1, I would think about it a little bit harder.
Hey, what are you doing?
I'm helping them.
Gosh. So we had D's and D's. Any other thing besides in question 1 besides D?
We're still getting a lot of D's and D's, but we're starting to see a few C's for the first question.
Okay. All right. Okay.
Some B's for the first question, but pretty much everyone thinks D for the second question.
Okay.
You want to go ahead and take a stab at the answers, Bob?
We'll start with the second question, right? Because everybody was saying D. So spot on. Azure SQL auditing, remember the DMVs we talked about, like sys.event-log, and then we put those type of number of successful connections and firewall, metrics into Azure. So Azure metrics and alerting can, so for example, you can set up an alert, Anna, to say, hey, if 10 people have failed to connect to my database today, I want to be alerted. Like a bunch of people are trying to connect in my database. Of course, advanced threat protection can even detect some of those scenarios. Let's do our process elimination for question 1. So sure. What following T-SQL is not supported for managed instance? So number 1, URL, the first one, is supported, right? Because that's how you're going to create your audit to Azure Blob Storage. B, external monitor, is how you're going to do like Event Hub, right? That's the other one you need. And C, you don't have access to the file system in managed instance. So I'm sorry for those that said D, but C is not possible. Therefore, D is not possible. Therefore, C is the answer.
Awesome. Thanks, Bob. And it looks like after, I gave a little hint, as I do, people started to think about it.
That's okay. We want them to know the answer, though, right? And again, notice how I limit it, though. In managed instance, you don't get access to the file system in the operating system. So anything like that, you're not going to be able to do. So if you create an extended event session, Anna, which you can do in managed instance, you cannot target it to a file. You target to Azure Blob Storage.
Awesome. Thanks, Bob. I really appreciate what we've done so far, and it seems like some people are liking your explanation. One person says, super explanation, Bob. So
Awesome.
Awesome. And let's go ahead and wrap up this unit, and then we'll take a 5-minute break. We're not done yet because we have performance. And this is a section you're not going to want to miss because Bob, the performance guy, talking about performance in Azure SQL, it's really going to be great. But in this unit, we talked about the security capabilities, and we kind of walked through from networking to authentication to encryption to, how are you going to monitor and manage this thing? So really we covered a lot, and there's a lot of hands-on exercises in this unit in Microsoft Learn. So definitely you're going to want to check that out.
Yeah, thanks. And I think we did a pretty good job of like no fluff today, right? I mean, I think it was not fluffy, but we got to up the game. We got to go harder, right? We got to go more technical. And so, security is an amazing and important feature for Azure SQL, but, keeping your assets performant, making them fast, keeping them fast is really important. So I look forward to showing some cool demos and talking about performance in our next lesson.
Awesome. Thanks, viewers. We'll see you in 5 minutes.
5 minutes.
Hi, and welcome back. We're excited to be back, and we're going to talk about performance now. And this is a really exciting one, like we were saying. Bob's been working really hard on this. I've been learning a ton from Bob on this. And so I think you all are going to learn at least a few things here as well. Now, when we start, similar to security, we want to start by talking about the capabilities. And so we're going to talk about how this relates to CPU, memory, I/O, all the things that you've worked on deeply as a SQL Server professional, whether it's partitioning, in-memory OLTP, and some new things around intelligent performance that have landed in the last 2 releases of SQL Server, but are also landing in Azure SQL, as well as some things you get only in Azure SQL database today. Then we'll talk about some of the tasks, and Bob will take us through some various scenarios. Now, Bob, when we start to look at performance, what really stands out?
Well, first of all, you need to know, if you're a SQL Server person, does Azure SQL have the capabilities I have in SQL? Like, do I have the right capacities to go, have enough memory, CPU, IO resources that I would want normally from a SQL Server? Can I do indexing? Do I have Hackathon? Do I have partitions? Basic capabilities. Does that stuff exist? So when I build my app, I design my database, is this going to work in Azure SQL? So we got to cover that. And then this is really important, especially monitoring. Do I have all the tools I want? Anna, do I have DMVs, extended events, all that stuff I'm used to make sure I can monitor my application? But I also got to know, how do I make it faster? If I need to make it faster, are there things in Azure to even automate some of that stuff? So that's the kind of stuff I think it's important for us to go cover today.
Awesome. I think we're also going to geek out a bit too.
Oh, absolutely. We got to geek out. Come on. This is a Anna Bob talk. It's got to be a geeky talk, right? Hey, first of all, you got to know what kind of capacity you have. We've talked about different deployment options. So usually when people ask me, what are the maximum capacities I have? So for example, for Azure SQL Database itself, putting hyperscale aside for a second, these are the maximum capacities you get for cores, memory, and for database sizing. So if you're thinking about, do I want to go to Azure SQL Database? Know that number one, you got some pretty good options here, and then you have some limitations that may or may not affect your choice in application. But for hyperscale, and we mentioned this before, you get 100 terabyte max database size in your environment, plus great number of cores and memory options as well. Now for managed instance, because of this virtual cluster concept, the capacities are a little bit different. In some cases a little bit less, and in some cases a little bit larger from database size. We'll talk a little bit about how the database size is more for your overall storage, not just for a single database. Now indexes, hey, all the indexes you know and love are there, clustered, non-clustered. All the stuff you can do for indexing is available for Azure SQL, including online and resumable indexes, which we've enhanced over the last few releases. And then column store, one of the most popular indexing techniques for read scale queries, is available almost in all the different tiers we option for Azure SQL. There's a few that it's not in, but for the most part, you get Azure column store indexes about anywhere you need it for Azure SQL. In-memory OLTP, codenamed Hackathon, is very specific to business critical. So you only get that feature, but it's fully supported there. In fact, we do things like create a memory optimized file group by default for you when you deploy, so you don't have to worry about those kind of type abstractions. And since it's a memory only capability, it's going to be a subset of memory you get for Hackathon of your overall memory limit for your deployment. Now, there are other things you need to consider as far as capabilities go. And so if you think about in terms of partitions, which is a very popular feature to kind of partition out your data, it's there. It's there for Azure SQL Database and Managed Instance. You only have file groups, though, in Managed Instance. So if you want to place your partitions in different file groups from a manageability perspective, you're only going to get that option in Managed Instance, but you still can partition your data if you'd like to do that in Azure SQL Database. And then I spent a lot of time, Anna, last year talking about 19 performance enhancements, like intelligent query processing and so forth. A lot of the things that we have, like intelligent query processing, which we'll talk about later, it actually started in the cloud. And so you have those capabilities in Azure. There are a few things, though, that we did in the engine first in SQL 19 that has not made itself into the cloud. But with our versionless type process we do, I expect all those kind of type things to show up in there. IQP being one of the biggest things that we do, that is there in Azure SQL, except for this one scalar UDF, which if Joe Sack is listening, the pressure's on Joe. We got to get that into Azure SQL. So he knows that. He hears it from me all the time. So those are kind of the capabilities to know what you have. Now, we talked about configuring a managed instance in a database. What about specific things for performance? Let's pick out a couple. TempDB, the bane of my existence. First of all, don't worry about I/O. We put them on local SSD drives all the time. We just manage that part for you. But the number of files can be important for allocation concurrency. You've seen that before from latch contention. So for Azure Database, you never get to choose the size through T-SQL. In fact, you don't have any options in Azure SQL or Managed Instance to use T-SQL or SSMS to change the properties of TempDB. We choose those for you. For Azure SQL Database, we're going to scale up those files based on your core choices. And for Managed Instance today, we just pretty much fix it at 12 files. We're kind of looking, though, can we enhance that a little bit in the future? Right now, 12 seems to be a number that even for very large core deployments has worked very well for customers. What other configuration things you got to think about? Well, we talked about configuration for databases, and we talked about alter database and alter database scoped configuration. The biggest one to keep in mind from performance, as I mentioned earlier in yesterday's lesson, is full recovery. So we only support full recovery for SLA purposes, and therefore, why is that important? Because minimal logging is not supported in that scenario. So if you're doing bulk operations, you got to keep that in mind, although you can do a bulk operations in TempDB because that is minimally logged. Now, everybody wants to know how to put files in their SQL Server. What disks do I put them on? Should I still put them on separate drives? Those kind of type things. In Azure, we handle all physical file placements for you. Well, does that matter? Well, if you look at the I/O promises we make in terms of latencies and IOPS and max sizes and rates, it shouldn't matter because you get to choose what those rates look like depending on your deployment choices. Now, you can, though, through Managed Instance, decide the number of files and the file sizes that you get for your database, and you can add files, and that could affect I/O performance actually in the general purpose case, and we document why that might be important to you. Max degree of parallelism, another important concept for configuration, and we have a really good story here in that pretty much everything that you can do with SQL Server, we support here through either Azure Database or Managed Instance. Just know that there are some limits. So depending on your vCore choices, we may limit what is that max stop that you need. But I believe all the choices are there for the parallelism that you need, especially when it comes to configuring max stop to not go too far, right? If you want 8 vCores, we support a max stop of 8, but you can tune it and you can configure it through all these different options, including query hints are supported through T-SQL. Now, if you notice on this last one, it says max stop for MI, Managed Instance, supported with Resource Governor. That is because for Managed Instance, we do support user-defined workload groups and pools for Resource Governor. So if you need that functionality and you like that today for your application, it could be used for affinity purposes, it could be used for all different reasons. We support Resource Governor for Azure SQL Managed Instance. Again, that's an instance level feature. This is why it's not available in Azure SQL Database.
Now, Bob, you've talked about configuring for performance, and you've also talked about indexes a little bit and how indexes are supported, every index I want, but a lot of times I'm going to have to maintain these indexes and maintain statistics and maybe maintain other things as well. Can you tell us a little more about how you maintain for performance?
Yeah, if you think about it, it really comes down to two areas people usually maintain: indexes and statistics. And all those capabilities that you're used to doing exist in Azure SQL. And of course, you have SQL Agent or Elastic Jobs, so you can even schedule these things. A lot of people have different advices there, Anna. Should I rebuild? Should I reorganize? When should I do it? Should I use automated stats updates? I'm not going to dive into those recommendations because those recommendations are the same for SQL Server as Azure SQL. Just know that the capabilities that you want exist here, whether it's doing a configuration for the database or it's actually doing an alter command, whatever you need, online, resumable, in these operations, they exist all for your capabilities. So index and statistics, just have comfort that things you're used to doing, your toolkit should work really well in the Azure SQL environment.
Awesome. So this is one of those examples where we would say it's just SQL.
It's just SQL, exactly, yeah.
Awesome. So here we are at a knowledge check, and we're amping up the difficulty level here, and we're also throwing in an extra question.
They look easy, right?
They look easy. Bob says they're easy, so no pressure.
No pressure, yeah.
Let's walk through these, and we'll give people a few moments to put in their answer. So the first question is: the number of files for TempDB is configurable for Azure SQL DB by which method? And the second question is: you can configure I/O performance for Azure SQL Database by which method? And then this last one is: how do you maintain indexes with Azure SQL? So to me, one of these is relatively easy, and the rest you really have to think and make sure you're paying paying attention. What do you think, Bob?
Well, we're flipping this model in this module, right? You're taking these on, and I ask you, right? Is that no? Okay.
No, I think I'll let you answer.
No, you know these. You know these. It's like Sherlock Holmes. Just apply my methods, right? So what are we getting out there, Anna? What are you seeing?
Yeah, let's take a look at what we're seeing. So I'm seeing a lot of C, actually only C's for the first one.
Okay.
For the second question, mostly B's.
B's.
And for the third question, mostly A's. So what I'm seeing the most is C, B, A.
Any other answers are being thrown out there on some of these, or?
There are some A for the first question,
okay,
or C for the second question.
Okay. Yeah, let's kind of work through these a little bit. Let's do our process of elimination here. So let's look at the first one. So the number of files for TempDB. So number one, I think I mentioned that you cannot use T-SQL or SSMS to configure TempDB at all in Azure SQL Database. You're blocked from that. So therefore, C has to be the only answer, right? Because A and B don't apply. And we didn't put that much of a trick on to give you no answer here. So it turns out is you change vCores through the Azure portal or through CLIs for Azure SQL Database. You can see in a table that we have, we can up and scale up the number of files for TempDB for you. And I think you're going to find that scaling is going to work great for your application. I think it meets the needs of what you need. So, I think people like this. Just pick your deployment, and we just put the number of files out there for you that meet your needs. So that's number one. Number two, the idea is configuring I/O performance for Azure SQL Database. So A, you don't get to choose where your files go. Remember that statement? So it doesn't matter about Azure Premium Storage. We may do that for you, but you don't get to choose that, so that can't apply. We do allow file groups in Azure Managed Instance, but not for Azure SQL Database. But you can't specify the physical location anyway, so C can't apply, so B must be the answer there. And then for the last one, all deployment options support rebuilding indexes, so B can't be it. It's not a specific one. And online index rebuilds are supported in Azure SQL, so it can't be C, so it must be A. So C, B, and A, yeah. And I think a lot of people got that.
Yeah, I think the majority of people got that. A few people got a little tripped up on 1 and 2, but yeah, I think these are great questions, and I'm glad to see that our viewers are learning.
That's right. Learn live.
Learn live.
Learn live.
All right, onward and forward.
Yeah, and monitoring is just huge, and and support. I lived this. I lived monitoring SQL Server, but you got to monitor things outside of SQL. So Azure Monitor is going to give you some options to do monitoring of things like you might do, say, in perfmon. We're going to show you some of that. But DMVs, extended events, those are critical. We should talk about those a little bit more deeper. But let's talk about a few things. Lightweight query profiling, really a great feature, on by default, allows you to look at a long-running active query and look at the plan in progress. It's in SQL 19, it's in Azure SQL. And query plan debugging, use this stuff all the time. Graphical plans, set statements like set show plan on, set statistics, IO, time, all that stuff works for you to go look at your query plans. And then query store is critical. On by default, and we power so many things with query store that you're going to see in this lesson today, including some interesting visualizations in the portal that are lit up by looking at that query store data. So query store, extremely important, on by default for both Azure SQL and Managed Instance.
Now, Bob, I always joke, and maybe I joke too much, that you are hyper-focused.
Yeah, I don't know where you get that.
So, can you tell us, I know you studied this topic very deeply, can you tell us more about what you found when you looked at DMVs and extended events? Absolutely.
DMVs, one of the core features that we've added to SQL Server over the years, starting way back into 2005, to look at a snapshot of what's going on in your server without needing a debugger. That's actually why we built this feature. We didn't want you to have to use a debugger. Who wants to do that, right? So you can run SQL queries to look at data. So for Managed Instance, you're going to love this. It's a SQL Server instance. So any DMV that you need is available as a SQL Server. Now, we got some new ones though, like Server Resource Stats is going to be something you can use to look at the overall resource usage from a CPU, memory, IO perspective of your Managed Instance. So we're actually going to give you some infrastructure type information in a DMV for a Managed Instance. For Azure SQL Database, since you don't get access to the dedicated SQL Server instance that's hosting it, and it's not an instance, you're going to get common SQL Server DMVs All the ones you typically know and love are going to be there. Some that you really need to geek out on, maybe really deep down, you may not get access to, but I believe the ones you need are going to be there. We're going to show you an example of that in our demos. Now we need to provide you, again, just like for managed instance, some resource stats. You want to take a look at some utilization of your resources. So we're going to expose them some DMVs, both for a single database and a pool resource stat usage, and I'll show you in a demo what that actually looks like. There are some DMVs that you're just going to need. Like DMO virtual file stats is very important. Since you don't have access to perfmon behind the scenes of the operating system, this is your best way to go look at file latency IO type performance of what's going on. Now we've always had for SQL Server performance counters, this DMV, DMO is performance counters, and we light that up. So if you like using that today to poll and look at that information, you can't use perfmon, but you can go look at a DMV to see what those SQL counters look like batch requests per second. You get to go look at that with this DMV. Now, we talked a little bit about this earlier about some DMVs to look at from a programming point of view, programmatically point of view, look at your configuration, Anna, your limits. So instance resource governor is used for managed instance, and user DB resource governor, which could be used for MI, but also for a single database. I love that because you can take a look and see what are the limits I have through a T-SQL query without having to actually go into the portal or use another as CLI. But as you said, you want to geek out a little bit, right? And we're the SQL Server team. So we're going to expose some DMVs that may not necessarily be documented, but kind of give you some pretty cool insight. These last two, for example, the first one is only available in managed instance, but the last two are pretty interesting. We actually use those in engineering to debug problems. We look at a history in here of governance going on behind the scenes of background tasks and user load to kind of look at possible customer problems. So you want to geek out and really get into some internals, you can go look at those DMVs. But let's talk about X event, one of my favorite topics. Extended event, also known as X event, is the tracing mechanism for SQL Server. And so for Azure SQL Database, we're going to give you that functionality. We're not going to give you all events. Again, we're not going to expose everything to the dedicated instance, but most of the common events like SQL statement completed, for example, is going to be there for you. And actions they're used to using are going to be there, like actions being those orthogonal events, like what's my SQL text, what's my session ID, those are going to be there as well. The biggest difference you're going to see is targets. You have ring buffer, you have counter targets, you don't have access to live data targets, but you do have access to a file target. And again, you don't have access to underlying file systems, so you need to use Azure Blob Storage for your X event. But it's very important, if you think you can't do tracing in Azure Database, you can. And you can use X events for that. What about for a managed instance? Hey, everything is there. Everything like a SQL server, all events, targets, and actions are all there. And remember again, that file targets need to go to Azure Blob Storage because you don't have access to the underlying file system. And if you really want to geek out, Anna, there are actually some new events that are specific to managed instance where you can kind of track what's going on behind in the infrastructure. We don't document all those things, but some people will just dump out the DMVs that show you all the X events, and you're going to find a few there for managed instance that are inside looking at that DMV for what objects exist. So that's kind of DMVs and X events. You have just about everything you want to do to monitor SQL Server.
Awesome. Now, let's switch gears slightly, Bob. And
Sure.
You've been in support, or you were in support for just a short while.
Yeah.
And we've learned about these tools. I want to take a look at the scenario. So let's say, I get a call around 2 a.m. and there's some performance issues with my Azure SQL database or my managed instance. I think you've probably taken a few calls like this in your time at Microsoft. Can you tell us, how do we approach that type of scenario?
Well, I'll age myself and used to say I used to get paged on those kind of scenarios.
What's a page?
Yeah, what's a page? What's a page, Bob? So my longtime colleague Keith Elmore in support, who just one of my best friends, he's still in support, by the way, focusing on Azure. He's a performance guru. And back in the day, he sat down with me and Bob Dorr, my other colleague, and said, look, I've got this idea of how to break down performance problems for SQL Server in a way that can help our engineers and help customers. So we look at things from a running or waiting perspective. So the first thing you need to do is look at your resource consumption or utilization. And the way you would do that with Azure SQL is look at these new DMVs I'm talking about, or you can look at the portal, PowerShell, alerts, those kind of type things. So you want to find out, am I running, which is CPU scenarios? Like, do I have high CPU situations? And that is usually caused by some execution of a query plan or even things like compilation. Well, how do you figure that out? Like if you are running and you've looked at these resource usage, you would then dive in to these kind of resources and tools, which we talked about. Query store, looking at certain DMVs, and what an interesting scenario that an actual wait could show up as a running problem called SOS schedule yield. And we'll kind of look at that in our demonstration. So that's the running scenario. Let's say it's not high CPU, okay? If it's not high CPU, you must be waiting, and you must be waiting on probably one of these categories. It's really funny how these categories line up because a lot of them match into what shows up in the query store, because the query store does support looking at waits. But typically you look at DMVs like OS wait stats, look at all your waits. You may look at exec request to see what is currently waiting. What am I blocked on, for example, in a blocking scenario? Or you might look at OS waiting tasks for parallel type queries. So I love the way to break this down, Anna. You look at your top, what do my resource consumption look like? Is it high CPU? Is it not high CPU? If it is high CPU, it's a running scenario. I must be waiting on a resource if it's not, with this one little caveat that one of the waiting scenarios also is a high CPU scenario, which is this case of SOS schedule yield. So that's how I break these things down.
Yeah, Bob, I think this is a really great way to break it down. You know, I think people would love to see you monitor performance in action.
I think it'd be cool. Let's try one. Let's do it.
Awesome.
Okay. Let's try it out here. So what I'm going to do is share my screen. And what I think I'll do is this. I've deployed an Azure SQL database that's 2V core, general purpose 2V core. Let's kind of make it simple. And I am going to connect into Management Studio using the network security connectivity options Anna showed me how to do. So I'm connected into my logical server, and I've got a database called AdventureWorks Azure LT. So what I'd like to do is I'd like to first kick off a workload and then talk about the workload and monitor it. So let's run this SQL workload CMD. Okay, now let's go find out what this thing is doing and monitor it. First of all, let's look at DM exec request with a join here and see what's happening. So by first of all looking at this, I can tell already here that I've got a lot of SOS scheduler yield waits. You guys see that right there? And I've got a lot of queries in a status called runnable. That's the first thing I notice. Now, I'm going to use that new DMV called DMDB resource stats and look at that. Now, I'm going to see very, very quickly here that I've got average CPU percent of almost 100%. This DMV is a polling DMV. We poll for you automatically. If you see here the timing of this, every 15 seconds to look at your resource utilization. And if I run it again, I bet I can see, oh, twice in a row now, I'm actually this. So this is starting to feel like over a 30-second period, a lot of CPU utilization. I suspect I'm in a running scenario. Let's take a look at the workload. This is just a join I'm doing in some tables in the AdventureWorks sample database. One little tip though, if you're kind of trying to do like CPU utilization scenarios, I'm assigning the results to a variable. So I'm reducing the result sets that might come back to my client, and I'm just running this in a loop. So I can continue to kind of look at this, monitor, see what's going on. I still see SOS schedule yield waits, runnable. I go look at DMDB resource stats. I'm going to run that again here. You can see now, Anna, over several intervals of collection here, this is a high CPU utilization situation. And if I go back and look at my client, I can see here I'm still running. So you may ask yourself, you know, this is bad, is this good? I've got 2 CPUs, I know it's running, and if you've ever looked at SQL Server before, this could be an indication of a potential problem. Because even though I'm using up CPU, I've got a high CPU utilization type query, I may be missing a resource here. So let's see if this will finish here. Yeah, this is finished, Anna. And if you look here, it finished in 1 minute and 50 seconds, which I don't know if that's bad or good. But let me go poke a little bit more at the query store. So I'm going to go over here. I'm going to look at query store and look at top resource consuming queries. You may have seen this report before, you may have not. This is showing that the query taking up the most duration during this interval is my query. This is the query I'm running down here. I can look at the plan down here. I can look at the overall statistics of the overall duration. Or this is interesting. At the plan level, I can see some averages. So I can see that the average duration, if you look here, is about 5 milliseconds. That doesn't seem bad, but if I run this a ton, that may not be optimal. So one thing I can do as well is look at query wait statistics and look at the fact that I'm waiting on CPU. Like, what the heck does that mean? That is equivalent to the SOS schedule yield wait. Now, if I look at the query that's waiting the most, it's my query. Now notice this one, this is interesting. The average wait time for this query on CPU resources is almost the entire duration of the query. This means for a query workload that's CPU dependent, I don't have enough CPUs. I only got 2 of them. That's why you see all these runnable queries, and you see this wait on SOS schedule yield. So this is a way for you to monitor through just SSMS and DMVs to see what's going on. Let's look one other method of how to do monitoring. Let's go over here and look at the Azure portal. And if you look here, remember we talked about, Anna, that you can measure performance outside of SQL. And again, you might use Performance Monitor. I'm looking at the Azure portal for what's called compute utilization. And you can see right here that I'm seeing 100% CPU utilization during the period of time that I ran that particular query. I can even do things like this. I can kind of drill into it with Azure metrics. I can add more charts to it. This is us using the Azure Monitor infrastructure and how Azure Database snaps into that so that you can monitor things outside. You can set alerts on this. I could have set up an alert to say, hey, if CPU percentage is 100% or near 100% for like a minute, send me an email or text me. That way I can kind of be alerted of a particular problem. One other thing I wanted to show you though, Anna, was logging. So I can actually redirect Azure Monitor to a log, which has a lot more history, and run something called a Custo query. So I'm going to go here and run this query, and I'm going to show you that over the last 24 hours, in fact, let me just pick it this way. How about the last 4 hours? Let's see. Yeah, look at this. So now there's no utilization for the last 4 hours, but again, if I go back to the 24 hours, because I ran this earlier, I can see that I had high CPU utilization before, almost 100%, because I ran this workload earlier this morning to see what it looked like. Now, logging is a little bit more delay than just seeing those metrics live, but it gives you a much historical view. Look here, I can go back over to the last 7 days or even to the last month to see what the performance was like for this deployment. So that's an example of using something called Custo, and that Custo you're going to see is applicable to looking at all sorts of types of things in Azure. So Anna, that's a little bit of look at monitoring, and in a second, we'll kind of take this demo and up our game a little bit, and we'll kind of scale it.
Yeah, that's awesome. And again, I know I've said this a few times, but you're actually going to be able to try this exercise and go through looking at the query store and your top resource consuming queries in the exercises, similar to how Bob just did today.
Yeah, Anna, that exact demo is in your Learn Labs for you to try yourself. Okay, so one thing I should mention, Anna, I didn't get to show you, but I'll show you in the scaling one, is that I used a program called OStress, and I've taught Anna how to use that tool in many different scenarios. You're going to see that show up in availability. So when I get back to the scaling, Anna, remind me, I'll show you what the OStress syntax looks like, because it's an easy way for you to test and simulate concurrent usage of SQL Server. So, we talked about those scenarios, running versus waiting, but is there anything specific to Azure? As it turns out, there are that you need to pay attention to. So first of all, transaction logging. In order to meet SLAs for things that we promised for you for availability, we cannot allow just unlimited use of the transaction log. So we have a concept called log governance. And so we have specific rules in the engine, depending on what deployment option and vCore choices you've made, of how much rate of transaction logs should we allow. And these are the type of wait types that you might can see showing up in the DMVs I talked about, in exec request or OS wait stats or those kind of type things, which I didn't show us wait stats, but in one of our other labs, we show you how to use that. But these waits could show up, and if you see them, oh, I got to go take a look at the log generation I'm making. How much logging am I doing in my application? And maybe kind of back that off a little bit, or maybe I need a new deployment option to get the amount of log rate that I need. So that's one of them. The other thing I've seen across my career is workers, the number of concurrent workers. SQL Server in Azure SQL uses a worker pool. And so people are used to looking at what's called max worker threads for SQL Server many years. And we automatically configure max worker threads for you in both Azure SQL Database and Managed Instance. But based in Azure SQL Database on your vCore deployment, we can throttle how many concurrent workers you're allowed. And that shows up in an error. Remember I mentioned, I'm going to mention at the end of our module, Anna, I think that's tomorrow or the next day, I'm going to mention that there are some new errors you need to be concerned with Azure, different than SQL, and this is one of them. Now for Managed Instance today, we do have a worker pool, and if you run out of that worker pool, thread pool waits, like you can see in SQL Server, may show up. We're kind of thinking, though, that we may need to make that also a limit in managed instance. We're still deciding on that because we've seen some customers that have bumped up their worker threads and caused performance problems for the application. But know today that max worker threads is something you can configure, and it controls worker limits for managed instance.
Now,
so, I'm sorry, Anna.
Bob, we have talked about how, like, there are some HADR weights for business critical, but we haven't talked a lot about, why would we see these? We haven't really talked about the architecture of business critical yet. So can you help me understand, like, why we would see these HADR weights?
Yeah, I'm sorry for interrupting. I was starting in my head thinking about what I wanted to say next, and I forgot you had asked me about this one. Yeah, we were building this slide, and I said, Anna, make sure you put in business critical HADR weights. And you're like, well, wait a minute. In fact, I think you showed this to a colleague, and they said, well, this is normal. HADR weights are normal for an availability group. And my comment was this: you don't deploy availability groups in Azure SQL. We do that for you. In fact, you don't even know. You just pick business critical. And behind the scenes, we happen to use that technology. So I've had customers that will pick business critical. Instead of seeing like write log weights, they see header sync commit weights. And they're like, I didn't deploy an availability group. Why am I seeing these? So my point, Anna, is that these are normal weights you can see in a business critical deployment scenario that you may not expect to see. So now if you had large wait times here, you need to go take a look at what's going on. We may be throttling you a little bit to keep up SLAs. But I think the important point here is that if you use a BC deployment, don't be surprised if these weights show up. And then finally, hyperscale, which we're going to get into the architecture of hyperscale during availability, but there are some weights that may show up for you called RBIO weights, and those involve log rate throttling to make sure that we're keeping our caches up to date and our replicas through log servers up to date. And know this, that in the architecture, you're going to see something called a page server. And we want to make sure we give you the right diagnostics in hyperscale. So we're going to add this page server information and infuse them into the various DMVs and catalog views and even Xevent. So if you need to do further diagnostics on what's going on from this page server perspective, you can do that as well. Now, Anna, I've showed you monitoring. I've talked about capabilities. But at some point, you want to make this faster, like my demo I showed you, right? So what about CPU capacity? Imagine, that you are in your environment, you realize you run the demo I ran and go, you know what? I don't think I have enough CPUs. And you're on a VM. You're running VMware and a host. And you're like, no problem. I'm going to go give myself more virtual CPUs for my VMware deployment. But then your administrators say, sorry, we don't have any more capacity on this server. Now what are you going to do? You have to go find another server and migrate your deployment to another server for a VM, which sometimes those vendors offer, even Hyper-V offers ways to do that, but you have to do the migration, not in Azure SQL. So we talked about different vCore choices. You can scale your CPU capacity through the portal, through T-SQL, which we're going to show you, through PowerShell or REST APIs. And there is some small downtime. Right at that moment, we need to flip you over to the new deployment, but it can be very, very fast, but there's no migration required. Now, sometimes the size of the database you have, like in a BC scenario, may affect how long it takes us to do this. But one thing I love about hyperscale is that no matter what you scale to and the number of vCores you need, it's a constant type operation. So that's scaling CPU performance. You get the ability to choose more CPUs you'd like, no migration required. Well, what about I/O? So we talk about IOPS, input output per second, and a lot of times I talk to customers about choosing that IOPS level in their deployment choices, and they haven't even measured that on premises, and they're not used to doing that. So make sure you know how to measure that through, like, say, Performance Monitor in your environment. That may show up in the form of longer I/O waits. And if you want to go affect IOPS or I/O latencies, it is typically about your choices of deployment. So it could be more vCores, it could be moving to business critical or hyperscale. It even could be, in the case of managed instance, changing the number of files or file sizes in the case of, say, like business general purpose, because we keep them in Azure Premium Storage, and the size of files affect which P level of Azure storage we pick. We've got some really good documentation around when you may or may want to do that. But think about transaction log scenarios. I've had customers come to me and say, I'm running what's called a singleton transaction scenario in a loop. Basically an insert is a commit every time. And I ran that on my SSD on my laptop, and I put it in Azure, and it's slower. And I'm like, well, do you get all the built-in HA with Azure? Do you get it on your laptop? Probably not, right? But this is where multi-statement transactions can come into play. So a lot of times customers may need to think about, are they efficiently running their app? And you'd be surprised, you move that model and your app is overall faster anyways. So memory and workers are an interesting concept about those resources. Again, memory is not something you're going to configure with, say, max server memory. You're not going to do those kind of type things. You're going to choose a vCore or deployment option to figure out how much memory do I get. And we already mentioned in the previous slide how many workers I get. And then finally, one thing that is missing is typically application latency. So we talked about proxy and redirect, and I can easily demo this in my demos I do. Redirect can be significantly faster for you, so kind of keep that in mind on the connection policy you're using. And then, Anna, one thing I've seen is just chatty applications. People that don't even use stored procedures or just send a lot of traffic back and forth from their app, and then they'll move to Azure SQL database for their database, but their app's on premises, and then all of a sudden things get slower. So that chatty application style is something you need to take a look at, or even just take advantage of basic things like batching. And in fact, speaking of that, if you look at these categories right here, it's comparing SQL and it's very configuration oriented. But what about just best practices? This is still the SQL Server engine. So indexing, batching, stored procedures, parameterization, processing results correctly, those things that you need to do in SQL Server environment all still apply in Azure SQL. You're going to see, though, in the case of like indexing, we're going to give you some help in the case of Azure SQL Database. But don't forget these tried and true things that you need to do, which kind of speaks volumes to the fact that people that have these skills are still definitely needed in Azure SQL scenarios.
Awesome. This has been a lot, Bob, and I love the it's just SQL theme riding over everything. Now, we talked about accelerating and tuning. Can we go back to what you showed us earlier and see how we could maybe scale that up?
Well, think about what I showed you. I showed you a 2 vCore deployment. In fact, let's just kind of share this out again. Let's go back over here and share out what we were looking at. And if you remember, in fact, I'll just bring the portal back up over here. Let me go here and bring the portal up. We had a general purpose 2 vCore scenario, and we still see our graph here for our CPU utilization that we had. So I have determined by just looking at this that the query plan's fine. I just need more CPUs, but I don't want to migrate. So one thing I could do is I could click here in the portal, and I could come through with a very handy dandy little slider and just pick more cores, hit apply, and we would automatically scale up what you're doing. Let's go see what this looks like, though, through T-SQL. I'm kind of a T-SQL person, right? So let's go do that. And so I'm going to remove this report that I was running, and I'm going to go look over here, first of all, at a query that's going to show me what is my current CPU core deployment. This is, remember that DMV we talked about to look at resource, this is my limits, but database property EX has also been enhanced to show you something called a SLO, or service level objective. That falls in line, the service level objective falls in line with my general purpose 2 vCore, for example, right? Gen 5 hardware. And you can see here these names, and we have the documentation that maps what those look like, but you can see here, I'm general purpose Gen 5 hardware 2 vCore. And if I look here, I'm limited to 2 CPUs. So what I can do is I can come over here and I can use Alter Database. We've enhanced Alter Database in Azure only to change this service objective. So I'd like to go to the same general purpose, Gen 5, I don't go to 8 vCores. But before I do that, I'm going to flush the query store. I want to make sure that anything in memory for query store is going to be seen. So when I show these reports, you can kind of see the differences. So, okay, so I'm going to alter database. I'm going to run here. Now, notice this came back immediately. Now, it doesn't mean that we've automatically moved to eight cores. In fact, if I go to the portal here, I can see that it's showing that I'm doing an updating of this, what's called pricing tier. And pricing tier means the things we talked about, service tier plus compute tier plus hardware, all kind of combined together, because it does affect the price of your deployment. So Anna, what this means is it's a deployment operation I'm doing. So Alter Database can effectively do a deployment. And the deployment is, I would like a new service objective. And so if I go back over here, I'll see if I run this now, I can see that's that quick. I mean, within seconds, I moved to an 8 CPU. It doesn't always happen that way, but in this case, it did happen that way. So let's run the workload again and see what happens. So same workload, and I think I promised you to show you what the workload was. This is OStress, this tool, free for you to download. I'm connecting to my server. I'm running the query I mentioned already. Remember my workload query. Here's my user. I'm using SQL Auth in this case. Here's my database, and these are the two important parameters right here. This is 10 users concurrently running a loop twice. So 10 users, twice run this query over and over and over. And Q means quiet mode, like don't process results because I don't care about results in this case. So if I run this, and this is a common tool I use all the time for these kind of type scenarios, I'm going to run it again. Now let's go back and do our monitoring with the same techniques. Let's look at exec requests. Exec request. Now it looks a little different this time. You still see some SOS scheduler yields right here, right? But notice that more of the queries are in a running state. What this means is I have more schedulers available to me to run my workload. Where I only had 2 before, I now have 8. So let's go back and run that again a little bit and see what it looks like. You can see it. In fact, it looks like it's almost finished. And if I go over to resource stats, what does that look like? This is interesting. Now it says 58 and 80, but that's an average across these 15 seconds. So clearly it took less CPU utilization to run the workload. And in fact, if I go over here, this is finished in 33 seconds, a significant increase or decrease in overall duration and increase in performance from like what, 2 minutes that it took before. So what about the query store? Does it show up? So we'll go back to the top resource performing queries. Notice that I have 2 query IDs now. Now what's interesting here, Anna, is that because we allow parallelism in the 8-core case and not the 2-core case, I do get a new query ID for the same query text. But can you see the difference in duration here? And if I click here, I can look at the plan, and I'll look here and notice the average duration is now almost like a little over a millisecond. And then if I go look at wait statistics, I still have some waits on CPU, but significantly less waits with this scenario. In fact, if you look here, you can see the average wait time is a lot less than the overall duration compared before where it took up most of the duration of the query. So a great example of showing how I can use T-SQL to just automatically, to manually scale this workload. And if I flip over to the Azure portal, I'm not sure it's shown up yet, but one thing that will show up here is a difference in CPU utilization down here on compute. Now, one thing I want to point out that's interesting that may not be obvious to customers, because we talked about a lot of different things in this lesson so far, is if I would have picked serverless as my initial deployment, I could have picked a max of 8 vCores, a min of 2, and I would only be billed on the max vCores when I use max vCores. Normally, I'd be billed on my min vCores if I wasn't even running that workload. And even better, if I had set up auto pause, when I'm not using it at all, I'm not billed for any compute utilization. So this is a way that we support auto scaling for an app that I showed you how to do manually scaling. So that's pretty cool. It's a pretty cool option for you to consider to use Azure SQL Database. But this is a good way to kind of show that the tools you're used to use and know and love, plus the Azure portal, can be used to monitor and to scale your workload.
Thanks, Paul. I think that was really interesting. And again, this is something, our viewers can actually go and try for themselves.
Absolutely. You're going to see those labs are available to you in MS Learn for you to try yourself.
Now, so, Anna, we have about 10 minutes left, and the last performance topic we want to talk about is related to intelligence. Now, we talked a little bit that Azure SQL supports things that SQL Server has today, like intelligent query processing and automatic plan correction. Now, using the power of Azure and some of the extra access we have in Azure SQL Database, we can do things like leverage machine learning to do some extra intelligent type of things. Bob, can you take us through some of the things that are in SQL Server and Azure SQL, as well as what's new?
Absolutely, and I like the word intelligent performance because it's not just about us making you run faster. We want to actually make you intelligent, and we want to do things to avoid application changes. So let's just briefly talk about IQP and automatic plan correction and talk more about automatic tuning. Intelligent query processing started in the cloud, and really this is what it's all about. We've enhanced the query processor so that you don't make changes to your app and you just get faster. So improve performance with no code changes. And the way you light that up is it's not a feature. You just go to the latest compat level, and internally the workloads that you run are going to get faster. So don't think of something that you go pick in the portal or something. You just change your compat level behind the scenes. We're going to try to make your workload run faster. And Anna, in the SQL workshops resources that we've pointed people to, have a whole set of labs in SQL 19 that you can do to try this out. And all that stuff applies to Azure. Now, automatic plan correction is very interesting. It's a scenario that we added in SQL 17, also in Azure. And it's really about query plan regression problems, such as parameter sensitive plans or parameter sniffing, as people call it, is a scenario where, if you see in this diagram here, a given query plan was fast, it got evicted from cache, a new query plan is compiled based on data that's skewed, and so a really bad plan gets into cache and everybody has to use it. So it's a query plan regression problem. Automatic plan correction can use the query store to recommend how to go back to the plan that was fast. Or if you turn it on by default to fix the problem, it'll automatically go back to last known good, back to a previously good plan. That's not in the engine. It is in the engine. It's not in the query processor. It's built into the query store functionality. So if you turn on query store, you get this functionality for free in SQL Server and Azure SQL Database. But let's talk about automatic tuning. Now, technically, automatic plan correction is part of the automatic tuning family. But we decided as part of Azure SQL that we would develop technology using a machine learning approach to combine things like DMVs and query store to give you recommendations or to automatically apply indexes for your environment. Now, Anna, we've had a history in SQL Server of DMVs that talk about missing indexes. You can see it in your query plan. The query store can help you point that out. But we thought we would do a value-added service behind the scenes that monitors your workload and then gives you recommendations through DMVs or in the Azure portal for possible indexes that you should create or potentially even drop. And what's really cool about this is that if you turn on this functionality, we can monitor for indexes that did get applied and then drop them if necessary. Or even better, you can just turn it on and we'll just do it for you. So automatic tuning with Azure SQL Database refers specifically to the automatic indexing feature that we supply if you deploy to Azure SQL Database.
Awesome. This is great, Bob. We still have a little bit of time, so I think it would be great if you have something, if you can show us, what this looks like.
Let's just take a brief look at what the possibilities are as we're running here to the end of the session. Let me share my screen again. So we've built a workload that we demonstrate this for. You yourself could demonstrate this, but be careful. If you're going to demonstrate this, you just can't run query one time and all of a sudden, boom, we just start doing indexes, which you want. We're going to monitor this workload over time to make sure it's something that can really make a difference. So in the Azure portal, I could look at something called Query Performance Insight, which is a visualization to look at query performance in the query store of your database. And you'll notice here at the top, we have looked at your data behind the scenes, not your data. We've looked at your queries behind the scenes, your workload, and we have recommendations for you. We call it Database Advisor. And these recommendations could involve indexes that you should create or indexes you should drop. And we even have a history here of tuning that's been done. And if you go through this process and you like what we've recommended, you can automate this. You can hit automate, and at the logical server level or at the database level, you can say, I'd like to turn on create indexing and drop indexing. And then we would monitor your workload over time. We would create indexes. And if we monitored and saw that that index caused worse performance, we would then drop the index. And you can see the history of everything we're doing. Or you can just look at recommendations. And these recommendations can also show up in a DMV. So you can actually programmatically look at what are we recommending over time as far as indexing. And notice here, the forced plan option is that automatic plan correction option as part of this suite. So great example of us using machine learning technology, machine learning models, mathematical models to monitor your workload and help you automate the process of doing indexes in Azure SQL.
Awesome. Thanks, Bob. I think that's a really interesting one, especially, for folks that are managing a lot of databases. This can just help remove some of that management overhead.
Absolutely.
Now, I put some knowledge check questions up, and as people are kind of thinking about those, I wanted to throw up a question from Avi. And Avi asked, how is parallelism, MaxDop, affected when we upscale? I'm guessing scaling up. Do the execution plans are recompiled? So do the execution plans get recompiled?
Yeah, when you scale, we're redeploying effectively. We got to restart SQL Server somehow, right? So anything, cache is going to get evicted. So first of all, anything is going to get recompiled. And if you scale up, we could change MaxDop for you. We document what that looks like. So good example is in the 2 vCore scenario, MaxDop is 1. And when you go to 8 vCore, MaxDop is 8. So that is actually very possible that in a 2 vCore, you will never get a parallel plan, but an 8 vCore, when you scale up, we're going to restart SQL Server, recompile as you run queries, and you might see parallelism kind of kick in.
Awesome. Thanks, Bob. And thanks, Avi. That was a great question. Okay, so let's take a look at the questions on the page that we have for you all. So the first question is, which best describes IQP? And the second question is automatic plan correction can help recommend and fix which type of performance scenario. And finally, we're just kind of working through the things we talked about. Automatic tuning for Azure SQL Database can recommend and create indexes based on what information? So we'll give folks a few seconds to answer those questions.
Easy. All easy stuff.
Easy stuff. Easy stuff. Bob says easy stuff. So,
yeah.
All right, let's see. So what we've got in is not all the same answers so far. I've got C, B, A, B, B, A, B, C, A, C, C, A. So maybe not quite as easy as we thought it was, or you thought it was.
Oh, okay. Well, all right. You want to go through?
It does look like we're getting a decent number of CCA, BBA. It looks like for the most part we're in agreement for the last question is A. For
the last one?
Yeah. Well, but let's go ahead and talk about these, Bob.
Yeah, let's just start with the last one. So we just talked about automatic tuning. So first of all, we don't look at query plan details for automatic tuning. We don't look at the query plan details, so it can't be B. We don't use extended events, so it can't be C, so it's got to be A, which is combining query store with DMVs to go figure out how to do indexing for automatic tuning. So for 3, the answer would be A. So for number 2, remember automatic plan correction is about query plan regression problems. So we're not going to recommend indexes for automatic plan correction. All we're going to do is recommend that a particular query plan should be used versus another. So, and it has nothing to do with out-of-date statistics for inefficient query plans. It's more about a regression problem that has occurred because it's actually the same query. As it turns out, it's a new plan, but based on skewed data. And so parameter sensitive plans or parameter sniffing is one of those causes. So C is the answer for 2, I would say. And for IQP, let's see here. Yeah, automated statistics are something that's just there for SQL Server, so that's not IQP. A query store is not part of IQP because it's part of the query processor, so it's got to be C, which is built-in capabilities in the query processor enabled through a DB compat level. So CCA, there you go.
Awesome. Yeah, and I think a good number of people got that, but this was a great explanation for those that maybe were a little bit confused. I think that first one could have been a little bit tricky, but that's just me.
Well, just remember that IQP, it's a good one, Anna, that we hone in on because it's built into the query processor. It's not something for the query store, and automated stats have just always been there. So it's a query processor thing, and that's important to know, I think.
Awesome. Thanks. Now, if we summarize what we've learned about today, and really it's been a lot, we talked about security, but if we focus on performance for a second, you learned about the capacities and how you can choose depending on your max of CPU, memory, and I/O. We talked about resource governance and some of the weight types you might see and other ways you can monitor, tools you can use, how you might be interested or when you might want to scale up or down. Some new Azure functionality, you got to look at Azure Log Analytics, which you haven't really seen much in our sessions before, but something that you can use throughout all the modules, really. We learned about the query store and intelligent performance, including that new capabilities that you get in Azure SQL Database specifically.
Yeah, Anna, that's quite a lineup. And I hope folks that have watched today, maybe you watched yesterday, kind of feel like we upped the game a little bit, which is intentional. We want to make sure we provide you a knowledge of what you need in Azure SQL, but most importantly, you're comfortable that we have the capabilities and tasks both for security and both for performance. You can secure your assets just like SQL Server with Azure, and you can make your application run very performant. And you saw what we did. We show you value-added services that make sense to go in the cloud, whether it's advanced threat protection or automatic tuning. We're going to give you value-added services of why you might want to make that move to Azure. So I think it was a great session today. And tomorrow, Anna, we're going to still up the game. We're going to talk about the amazing built-in high availability capabilities of Azure SQL. If you've ever set up, configured a failover cluster instance or an availability group, you need to come watch tomorrow. You're going to love what we're going to show. We're also going to introduce you to some fun activities, some scenarios that we're going to kind of introduce to you because it's going to set you up for some homework assignments that we're going to do on the last day. So I'm looking forward to tomorrow, and it's going to be fun.
Yeah, tomorrow will definitely be a fun one. Between today and tomorrow, if you want to take a look at the Microsoft Learn Learning Path, I put the link up on the screen. There, you can try all the exercises from today related to security and performance in modules 3 and 4. You can also check out any of the other modules or hands-on labs that are there. We hope to see you again tomorrow at the same time, at the same place. And if you have feedback from today, please take a few seconds just to fill it out and let us know what you think, if we should keep doing this, if we should do something different. Any feedback you have, we would love to hear it. And we'll see you back tomorrow at the same place, at the same time. Thank you. Have a great evening, night, day, midday, morning, whatever time it is where you are. Thank you so much.
Thanks, everyone.